All right, so hopefully you gave this one a try before you watching the video. But let's go ahead and go through it. In this example, 2 dice are rolled, and the events T and F are defined to be, so F is the event of rolling a sum of 4, sum of 4, sum of 4. And T is the event that at least one die shows a 3. All right, well, and we want to find what's the probability of the union of T and F. So we're looking for either the sum is a 4 or, right, because union is or, the at least one die shows a 3. Okay, so we want either or both of those events to occur. Well, let's try and figure out what those events look like. So I'm just going to put it in raster notation. So let's think about all of the different ways that 2 dice could come up with a sum of 4, right? So we could have 1 and 3, or we could have 2 and 2, or we could have 3 and 1, right? That's all the ways that it could come up with a sum of 4. So that's our event F. And T, okay, well, we want at least one die to show a 3. All right, so let's just list them, right? So we have 3 and 1. We could have 3 and 2. We could have 3 and 3. We could have 3 and 4. We can have 3 and 5. And we can have 3 and 6. Okay, so that's the first die is a 3. And then we could look at all the cases where the second die is a 3. Now you have to be careful here because you might be tempted to just say, well, I've got 6 where the, in which the first die is a 3. So there would be 6 more, but be careful because there's a 3, 3. So let's just list them out here just to make sure that we don't mess this up, right? So now I'm just looking at all the cases where the second die is a 3. Now I don't want to list 3, 3 again because I've already listed 3, 3. So now the next one's going to be 4, 3, and 5, 3, and 6, 3. Okay, and recall that we're treating the dice as if they are, as if the order matters, in order to get mutually exclusive events. Okay, so it's just trust me. The order of the dice, just consider it as if it matters. All right, so now we've just listed out all these sets. So we can see that the number in F, the number of elements in F is 3. The number of elements in T is equal to, we got 6 plus 5 more, which is 11. Okay, because they have that one overlapping event. What we want is the union of the two, but we should probably look at where they overlap, right? So let's figure out where what's the number of elements in the intersection of F and T. Okay, so we just want to look at what elements do they have in common. So, well, you can see basically we have this 3, 1 and 3, 1, those match, and the 1, 3 and 1, 3 also match. So they have 2 elements in common, right? So the intersection is 2. Now we could put this in the Venn diagram if we wanted to. We don't necessarily need to in this one. You probably can figure it out without a Venn diagram, but I'm just going to go ahead and show it on a Venn diagram just so we can kind of visualize what's happening here, right? We've got 3 elements in the F set, where the sum is 4, and we've got 11 elements in the T event where at least one die shows a 3. And then we found out that there are 2 elements they have in common. So we know that there's 36 ways to roll a die, and then we can go ahead and fill in the rest of the Venn diagram. So there's 1 element in the F event that does not involve a 3, right? It's a 2, 2 element. We have, let's see, we're going to have 9 elements in the T event, where we get at least 1 3 that don't add up to 4. Okay. And then, so it looks like we have a total of 12 elements in the union of the two sets. So that means we'd have 24 elements that that don't involve rolling a sum of 4 or at least one die showing a 3. Okay, so there it is as a Venn diagram. But so what we're looking for, remember what we're looking for? We're looking for the number of elements in the union of the two sets, which means either you get a sum of 4 or you get at least 1 3 on the die. So so the probability of F union T is just going to be the number of elements in the union, F union T, divided by the number in the sample space. Right? So we get, we add these up, right? 9 plus 2 plus 1 gives us 12 out of 36, which is the same as 1/3. So we have a 1/3 probability of either getting a sum of 4 or at least one die shows a 3. Alrighty, I'll meet you for the next example.